Good afternoon, students. Hello. Hello, good afternoon, students. You are there?
Yes.
Okay, ma. Now slowly they are coming. 1:38. 8 minutes is over. (42). Okay, students, we'll start our class. Everybody write down. So we completed in previous class preparation, properties and applications of polyvinyl chloride and nylon 66, Teflon, polytetrafluoroethylene. So what we are going to discuss today is preparation, properties and applications of Bakelite. Right down, ma. Preparation, properties and applications of Bakelite. So we have to discuss preparation of Bakelite, its properties and applications. Okay. So first we'll start the preparation, ma. Okay, then we can go to the properties. So preparation of Bakelite. So Bakelite is it is an important thermoset resin. Okay, named after the scientist Backelite. So Backelite, the scientist only prepared a Bakelite polymer. So that is known as the given name is phenol formaldehyde resin. Phenol formaldehyde resin or phenolic resin. Okay, Bakelite. It is also known as phenol formaldehyde resin or phenolic resin. So this is synthesized by scientist Bakelite. So in the year 1909, so it is prepared by condensing phenol and formaldehyde. Phenol and formaldehyde. So it is prepared by condensing phenol with formaldehyde in presence of acid or alkaline as a catalyst. We will use acid or alkaline as a catalyst. Okay. So its commercial name, okay, for this polymer. Just a minute. No? So the Bakelite is the commercial name for the polymer obtained. So by the polymerization of phenol and formaldehyde. Okay, na? So it is prepared by condensation polymerization, Bakelite. So here, see the students, the initial reaction for the formation of ortho and para hydroxymethylol phenol. Okay, so which reacts to form a linear polymer novolac. So here what happens, see the, for example, this is I will tell you that. See ma, we are taking phenol. Students, you are listening to me? Hello? Hello, students? I will take the attendance after this class.
Yes, ma'am.
Tell all the students. This is important topic. On your video, this is important topic. Only 46 are there in the class out of 65. CR?
Yes, ma'am.
Send one message immediately. I will take the attendance after 5th period.
Okay, ma'am.
So preparation, ma, for example, this is step 1. Step 1. So we are taking phenol and formaldehyde and using catalyst, either base or acidic catalyst. So what we are getting in step 1 is we are getting ortho hydroxymethylol phenol and para hydroxymethylol phenol. So this is step 1. So we will take phenol and formaldehyde. When we are reacting these both, we are getting here ortho hydroxymethylol phenol and para hydroxy. So this is ortho meta para. Okay. So para hydroxymethylol phenol. Okay. So what we are doing here, we are taking, for example, orthohydroxymethylol phenol, and we are going for polymerization process. We are going for polymerization process. So what we do here, we got ortho and paramethylol phenol, and we go for polymerization process. When we are going for polymerization process, removal of water molecule will be taking place. Removal of water molecule, you can see here. So we are taking ortho-hydroxymethylol phenol and n number of ortho-hydroxymethylol phenol and undergoing polymerization process. Okay. So then when we are going for a polymerization process, removal of water molecule is taking place. Removal of H2O. Removal of H2O. So when removal of H2O is taking place, what we got here? Linear polymer, straight chain polymer, which is known as Novolac. Which is known as Novolac. So that is the second step. Second step is we are getting a Novolac structure, linear polymer. Linear polymer. Now third step, students, third step. So what we are doing third step is, so when Novolac resin is, now Novolac resin we will take, okay, now this one, Novolac resin. And now what we are doing to this Novolac resin, we are heating this Novolac resin further. Okay, step 3, we will heat the Novolac resin in presence of formaldehyde. In presence of formaldehyde, and we will add here hexamethylene tetramine catalyst. Hexamethylene tetramine catalyst. Okay, ma. So we'll take Novolac polymer, linear polymer. So in step 3, what we do? To this Novolac polymer, we will add here formaldehyde, and also we will add catalyst hexamethylene tetramine we will add, and we will heat that polymer. We will heat. So when we are heating, so what we get the students here? So when we are heating this soluble and fusible Novolac, it will converts into hard, infusible and insoluble cross-linked structure. Solid of cross-linked structure, Bakelite is formed. This is cross-linked structure, Bakelite. This is Bakelite. Okay. So what is the step 3? We are taking Novolac, we are adding formaldehyde and also hexamethylene tetramine catalyst, and we will heat that polymer. When we are heating, so the fusible Novolac resin, the fusible Novolac structure, it will convert into cross-linked structure. So that cross-linked structure is Bakelite. That cross-linked structure is Bakelite. This one. Bakelite cross-linked structure. So this is the preparation of Bakelite, but here I gave in different way. So according to phenol formaldehyde ratio, we will get 3 mark here. Okay, but the preparation you learn this only. This is the correct preparation method. But here what I'm going to tell the point is here. When we are reacting phenol with formaldehyde in presence of acid or alkali to produce, what all we will get here means monomethylol phenol. If you take 1:1 ratio, if you take according to phenol formaldehyde ratio, if you take 1:2 ratio, you will get dimethylol phenol. If you take 1:3 ratio, you will get trimethylol phenol. Okay. So, but we are taking here to prepare the Bakelite, we are taking monomethylol phenols. So when you are taking n number of monomethylol phenol, okay, and undergoing polymerization process, okay, ma. So what happens? Removal of water molecule is taking place. Nothing but it is undergoing condensation polymerization. We'll get a Novolac structure. This is a linear polymer. Okay, ma. So to this Novolac structure, students, we are going to add again formaldehyde, and we will add hexamethylene tetramine. So to this Novolac resin, we will add formaldehyde and hexamethylene tetramine. So when we are heating, we will get Bakelite structure, which is insoluble cross-linked structure. But Novolac is, that is a fusible structure. Okay, fusible linear polymer we get. So after that, that Novolac is converting into Bakelite. Bakelite is insoluble, infusible, cross-linked structure. So this is the preparation of Bakelite. So when we are taking a phenol and formaldehyde, so step 1, we are getting ortho and para-hydroxymethylol phenol. Now we are taking ortho-hydroxymethylol phenol N number, and going for polymerization process. Here it will undergo condensation reaction, condensation polymerization, removal of byproduct water molecule is taking place. Then we are getting a linear polymer novolac. To this novolac linear polymer, we are going to add formaldehyde, and also we will use the catalyst hexamethylene tetramine, so that it will convert into, we have to use compulsory catalyst, so that we will get the fusible novolac linear polymer to infusible cross-linked structure Bakelite is formed. Okay, so this is the preparation of Bakelite. Now students, tell me, what is the first step? You have to learn this everything. Tell me, what is the first step preparation? Students? Hello?
First, we mix phenol and formaldehyde.
Mm.
And
When
then
you are heating that, what you are getting?
Hydroxymethylphenol.
Hydroxymethylphenols you will get. Then what you are doing?
Then we are taking to polymerization, and then we'll get novolac, which is a linear polymer.
Linear polymer, okay.
And then we are heating it with formaldehyde to get Bakelite.
What catalyst we are using here? We have to add catalyst.
Formaldehyde.
No, formaldehyde is not catalyst. That is reactant only, chemical. Hello?
Yes, ma'am.
We are taking novolac and also formaldehyde. What catalyst we are using? What catalyst we are using?
Hexamethylene tetramine.
Hexamethylene tetramine. Okay. So when we are adding to the novolac resin, we will take formaldehyde, and also catalyst we use hexamethylene tetramine, and we are heating that. Okay. So then what we will get when we are heating that polymer, novolac?
Bakelite.
It will be converting into
Bakelite.
Bakelite. So Bakelite is a insoluble,
hard, infusible, insoluble solid.
Infusible, insoluble cross-linked structure. Whereas novolac is
soluble and fusible.
Soluble and fusible linear polymer. Okay, ma. So this is the preparation of Bakelite. Students, you have to write 1, 2. Okay, this is step. Okay, third step. Okay. So there are like 2 to 3 steps are there in preparation of Bakelite. So you have to learn this. Clear, students? Okay. So you have to learn this preparation method, and you have to write how to prepare the Bakelite. Now, properties of Bakelite. Bakelite is hard. Bakelite is hard. We'll make switchboard, switches. Okay, na? So Bakelite is hard, rigid, and strong. Bakelite is hard, rigid, and strong polymer. It is water resistant polymer. It is water resistant polymer, and it has got good chemical resistance. Resistance to chemicals, like resistance to acids, salts, and many other organic solvents. It is resistant to acids, salts, and many organic solvents. But here it is attacked by alkalis due to the presence of OH group. Okay, in the Bakelite structure you can see. So it is attacked by alkalis due to the presence of OH group. Okay, it is used for water purification. So polymers we will use for water purification. Okay, as anion exchanger and cation exchanger. But this Bakelite, we are using this polymer as anion exchanger. It is used for water purification by ion exchange process in boilers. Ion exchange process in boilers, because it is having the functional group OH. It is an excellent electrical insulator. Bakelite is excellent electrical insulator, and it has very good corrosion resistance, and it is resistant to O2, CO2, moisture, light, UV radiation. PVC is not resistant to UV radiation, but Bakelite is resistant to UV radiation. So it is resistant to O2, CO2, moisture, light, UV radiation. So it has very good corrosion resistance and resistant to O2, CO2, moisture, light, UV radiation. So these points you write, ma. Properties of Bakelite. So first is it is hard, rigid and strong. Water resistant polymer. It has got good chemical resistance. So it is resistant to acids, salts, and many other organic solvents. But it is attacked by alkalis because of the presence of OH group. It is used for water purification by ion exchange process in boilers. It is an excellent electrical insulator. So we will use switchboard, switches and all. It has very good corrosion resistance. Okay, resistant to O2, CO2, moisture, light, UV radiation. Okay, now applications. So applications, you can see switches. Okay, switchboard. It is used for making electrical insulator parts like switches, switchboards, plugs, etc. Next, for making molded articles like telephone parts, telephone parts, cabinets for radio and television, cabinets for radio and television. Okay, and we will use as an anion exchanger resin in water purification by ion exchange method in boilers. We will use as a anion exchanger resin. Okay, in paints and varnishes also we will use, and for making bearings. Okay, in propeller shafts, we will use for making bearings used in that we are using in propeller shafts. Okay, we are making with Bakelite only. In paper industry we will use, and rolling mills also we will use because they are very strong hard polymers. No? We will use in paper industry. Rolling mills we will use. Okay, na? And for making wood laminates also. So wood laminates, that is also Bakelite. Glass laminates also will take this polymer Bakelite. So many applications are there, Bakelite. So for making wood laminates, glass laminates, we will use in paper industry and rolling mills, and we will use in propeller shafts for making bearings that are used in propeller shafts, and as an anion exchanger, and telephone parts, and cabinet for radio and television, and switches, plugs, switchboards. All these applications you can write here for Bakelite, applications of Bakelite. Okay, so first you have to learn the preparation well. See, bangles, this is also Bakelite only. Okay, clock, all these applications of Bakelite only. Okay, buttons. Okay, these buttons also Bakelite only. Clear, ma? Okay, applications of Bakelite. So students understood, ma, preparation of Bakelite first. You have to learn the structures. Okay, na? Hello.
Yes, ma'am.
How many steps are there? Tell me. Immediately you are getting Bakelite. Huh?
3, ma'am.
You have to take first phenol and formaldehyde. Okay. So when you are heating that, you will get ortho and para hydroxymethyl phenol when you are reacting that both chemicals. So you are taking now you are going for polymerization process, taking n number of orthohydroxymethyl phenol, undergoing for polymerization process. So it is undergoing condensation polymerization because what is present in monomer? ఏముందమ్మ ఇక్కడ monomer is containing
OH.
So monomers which contain functional groups, it will undergo condensation polymerization. We know that already, students.
Yes, ma'am.
So here condensation polymerization is taking place, ma. Removal of water molecule. Here it is clear. You can see here. Here you see, ma, removal of water molecule. So what structure you will get, ma? Students, what structure you will get? I wrote N here. Okay, na? Novolac structure. So Novolac structure is, Novolac is what? Linear structure, linear polymer we are getting. Yes or no?
Yes,
Novolac is linear polymer. Then what you are doing after getting Novolac? What you are going to add? Tell me, to the Novolac what you are going to add?
Hexamethylene tetramine.
Hexamethylene tetramine catalyst, and also you are adding formaldehyde. Okay, so that you are heating. When you are heating that, you are getting now a cross-linked structure Bakelite. cross-linked structure, Bakelite. Clear, everybody? Clear, ma?
Yes, ma'am.
Now tell me what are the properties? Students, what are the properties of Bakelite?
Hard, rigid, and strong.
It is hard, rigid, and strong.
Water resistant polymer.
Water resistant polymer. Okay.
Good chemical resistant and resistant.
It has got good chemical resistance, resistant to
Acid, salts, and many
acids,
organic
salts, and
solvents.
many other organic solvents. Okay.
But is not resistant to alkalis.
Alkalis. Okay, because of the OH group. Okay, next.
It's used for water purification.
It is used for water purification. Okay.
Excellent electrical insulator.
Excellent electrical insulator. And it is resistant to
O2, CO2, moisture,
CO2,
light,
moisture,
UV.
light, UV radiation. Okay, so these are the properties. You have to learn the properties for form. PVC properties, nylon 66, Teflon, Bakelite. So for synthetic polymers, you have to learn the properties and applications. Preparation anyway, you have to learn. That is compulsory. After that, you learn properties. What are the uses of Bakelite? Students, uses of Bakelite?
For making electrical insulator parts like switches, plugs, switchboards.
Switches, switchboards, plugs. What else?
Molded articles like telephone parts, cabinets of radio.
Telephone parts, cabinets for radio and television.
In paints and varnishes.
Okay, we will use in paints and varnishes also. Next.
For making wood laminates and glass laminates.
Laminates, glass laminates, we will use in paper industry, rolling mills. And we will use as an anion exchanger resin for water purification. Okay. All these are applications of the Bakelite. Okay. Just a minute, students. Okay. Okay, students, just I will revise for 5 minutes more. Okay, properties and applications. Okay, and preparation so that we can go to the next topic. Now, students, tell me what are the properties of PVC? So PVC we are preparing by addition polymerization. We are taking n number of vinyl chloride molecules and applying heat, pressure, and catalyst, and we are preparing polyvinyl chloride. Students, how we are preparing Teflon? Tell me. Preparation of Teflon. Students, hello. Teflon.
Polymerization of tetrafluoroethylene.
Polymerization of tetrafluoroethylene. We are going to prepare polytetrafluoroethylene by addition polymerization. Okay. So PVC and Teflon, that comes under addition polymerization. So how to prepare nylon 66 ma? Nylon 66 preparation.
Hexamethylene and diadipic acid.
Hexamethylene diamine and adipic acid. What type of polymerization here in preparation of nylon 66? What type of polymerization process?
Condensation.
Condensation polymerization. So what is condensation polymerization? Hello? What is condensation polymerization?
It's having functional.
Monomers are having functional group. Okay, COH and H2. So what is mean by condensation polymerization? How you are getting the polymer?
By eliminating.
By eliminating the
Water.
water or HCl. By eliminating the water molecule. For example, here in adipic acid and hexamethylene diamine, when we are going for polymerization process, there is elimination of water molecule is taking place and getting the polymer product, that is nylon 66. So how Bakelite is prepared, ma? How Bakelite is prepared? How Bakelite is prepared, ma? Preparation of Bakelite. Hello, students. What are the chemicals we need in preparation of Bakelite?
Phenol.
Phenol and
Formaldehyde.
formaldehyde. Two chemicals we are taking, phenol and formaldehyde. So when we are taking phenol and formaldehyde, what type of mixture you are getting? What you are getting here?
Ortho
And para-hydroxymethylol phenol. So you are taking ortho-hydroxymethylol phenol N number and going for polymerization process. What type of polymerization is taking place here? Condensation. So removal of water molecule is taking place. What type of structure you got? Linear polymer. What is that name called? What is the name of that structure? Novolac. So to this Novolac structure, what you are adding? Formaldehyde. And also catalyst you are using. What is that catalyst?
hexamethylene tetra.
Hexamethylene tetramine. Hexamethylene tetramine catalyst we are adding. So then we are heating that. So when we are heating, what we got? What is this? Bakelite. So that is a cross-linked polymer. So out of these four, what we discussed, preparation, properties and applications, students. So polyvinyl chloride and Teflon. These two are, so we discussed that these two are prepared by addition polymerization. Whereas nylon 6,6 and Bakelite, so these are prepared by condensation polymerization. Clear, everybody? Now, what are the monomers we are taking in polyvinyl chloride? Monomers in polyvinyl chloride. No.
Vinyl chloride.
Vinyl chloride. What are the monomers in nylon 6,6?
Adipic acid and hexamethylene diamine and adipic acid.
What are the monomers in Teflon?
Tetrafluoroethylene.
Okay. In Bakelite, what are the monomers?
Formaldehyde and phenol.
Phenol. Formaldehyde and phenol. So Bakelite, the other chemical name, tell me. What is the other name? Bakelite, what is the other name? What is the other name for Bakelite, ma? You are not telling. Tell me, what is the other name for Bakelite? What is this?
Phenol
Chemical
formaldehyde.
name. Phenol.
Formaldehyde resin.
Formaldehyde resin. Phenol formaldehyde resin. Now you know the preparation, everybody. You have to learn. Okay. Now properties of PVC. 5 points are there. Properties of PVC. What is the last point?
It's not stable to heat and UV radiation.
It is not stable to heat and UV radiation. It will undergo degradation. But in Bakelite, what we discussed in Bakelite?
Resistant to UV radiation and
Resistant to
heat.
UV. It is resistant to O2, CO2, moisture, light, and UV radiation. Okay. What is the melting point of PVC?
148 degrees Celsius.
148. Nylon 66?
264 degrees Celsius.
64. Teflon?
300 degrees Celsius.
300.
350 degrees.
350. Okay. So now These 2 points you got. PVC is colorless, orderless, non-inflammable, chemically inert powder. So you write second point. It is resistant to light, O2, inorganic acid, and alkalis. Okay. So these are the properties of PVC. Now properties of nylon 66. So first point you write its melting point 264 degrees centigrade, and it have good strength. It will absorb little moisture. So these fibers are flexible. Okay. And it possesses high temperature stability, good abrasion resistance, and it is insoluble in solvents like organic solvents like benzene acetone, but it is soluble in phenol and formic acid. Okay. So these fibers are easily blended with wool to increase strength and abrasion resistance of wool. So you have to prepare properties compulsory so that you can write. Now students, tell me properties of Teflon. Hello? Properties of Teflon.
High density.
Now it is having high density. Okay. 2.1 to 2.3. Why it is having high melting point? 350 degrees centigrade.
Electronegative fluorine atom. Strong attractive force.
Strong attractive forces between polymer chains because of the presence of highly electronegative fluorine atoms. Okay. So that it is becoming, so this polymer is very strong, hard polymer. So we are using to machine that can be machined to drilling and punching. Okay. And also one good property is there. What is that Teflon is having? Good.
Abrasion resistant.
No. Good.
Electrical insulator.
Electrical insulating property. Bakelite also is having. Bakelite. It is also having
electrical
insulating property. Whereas Teflon also it is having electrical insulating property. Okay. Now last point. Last point in Teflon.
Very good abrasion resistance.
It possesses very good abrasion resistance. Very good abrasion resistance. So nylon 66 also it have good abrasion resistance. Good abrasion resistance. Whereas Teflon is also having good abrasion resistance. Good electrical insulator. Strong hard polymer. High density. High melting point. So these are the properties of Teflon. Now properties of Bakelite. We will repeat more. Okay. So Bakelite is also strong hard polymer. First point. Strong hard rigid polymer. Okay. It is resistant to, it is water resistant polymer. Okay. It has got good chemical resistance. So resistant to acids, salts and other organic solvents, many organic solvents. Okay. So it is used for water purification. Good electrical insulator. It is resistant to O2, CO2, moisture, light, UV radiation. So the 6 points you have to remember. Properties of Bakelite. Now students, tell me applications of Bakelite. Hello? We'll go to the next topic. Tell me. You have to know applications of Bakelite. Hello?
It's used to make switches, plugs, and switchboard.
Switches, plugs, okay. Switchboards.
In paints and laminations.
Varnishes, okay, laminates.
For molded articles like telephone parts, etc.
Telephone parts, okay, telephone parts, cabinets for radio and television. And also
anion exchanger in water purification.
Anion exchanger. Else, what else? What else
for
we use?
Pavings, used in popular shafts and paper industry.
Popular shafts we use, paper industry, rolling mills. All these are various applications are there for Bakelite. You can write. Students, tell me applications of Teflon, ma. Teflon applications. Teflon applications.
Teflon is a very good insulating material.
You're right. Where we are using Teflon in
Motors, transformers,
transformers, cables, wires. Okay, this point you can write. We are using in motors, transformers, cables, wires. It is having good in electrical insulating property. So we will use in motors, transformers, cables, wires. And also it is used in making gasket. It is used in making gaskets. Okay, we will use in pressure cooker also. Okay, gaskets, pump parts, okay, tank linings, tubing. Second point. Okay, pump parts, gaskets, tank linings. Third point, we will use in chemical carrying pipes. Chemical carry pipes and non-stick stopcock for burette. Non-stick stopcock for burette. We will use Teflon and non-stick cookware products. Non-stick cookware products. We will use the Teflon. Okay. Uses of Bakelite is different. We will use as water ion exchanger, anion exchanger resin, and we will use in paints, varnishes, wood laminates, glass laminates, and it is used electrical insulator, switches, switchboards. Okay, but here these applications of Teflon is different. So this is used in non-stick stopcock for burette, non-stick cookware products, chemical carry pipes, tank linings, gaskets, motors, transformers, cables, wires. Remember, applications you have to learn. Okay, for these 4 applications you have to remember, and properties. Now applications of nylon 66, tell ma. Applications of nylon 66. Hello? Hello students. Applications of nylon 66.
for fiber.
We will use as a fiber. Okay, we will make making socks, ladies causes. Okay, ma. And next undergarment dresses, carpets. We will make ropes, bristle for toothbrush, and tire cords, etc. Okay, we will use nylon 66. And next PVC. So rigid PVC, we will make sheets used in tank lining, safety helmet, refrigerator components. And plasticized PVC, we will use for making sheet, packing raincoat, tablecloth curtain, cables, wires, toys, okay, chemical containers. So all these applications you write for PVC. Properties you have to learn more. Properties and applications you have to learn, and preparation. Okay, students, understood ma? These 4. Hello?
Yes, ma'am.
So for these 4, for each one, first you have to learn preparation. You can write in chemistry notes when you are learning. So first you have to learn all preparations, write down one column. So next column you write properties for all that 4 properties. You start writing first learn properties of PVC, then write, then nylon 66, Teflon, Bakelite. So you won't get any confusion. You can read comparison also, because everything, all the properties will be different. You can remember the points. Then you write applications, uses of polyvinyl chloride, nylon 66, Teflon, Bakelite. You can read the uses and you can write in your notes. Okay. So when you are preparing, everybody prepare in this way so that there won't be any confusion for you. Okay. So next just I will tell you which topic we are going to discuss in next class. Tomorrow I will discuss. Okay, na? Just a minute, ma. Okay, na? Okay, so our next class, okay, what we are going to discuss is biodegradable polymers, ma. So this is the last topic we will discuss in polymers, biodegradable polymers. So in biodegradable polymers, we are going to discuss two types of synthetic biodegradable polyvinyl acetate. So we'll take preparation, okay, and properties and applications, and polyvinyl acetate also preparation, okay, properties and applications. So tomorrow we'll discuss this. Any doubts, students? Tomorrow we'll discuss slowly this topic. Okay, na? So students, any doubts, ma? Hello?
No, ma'am.
No, ma'am.
Applications you have to learn well. Okay, na? Shall I end the class?
Yes, ma'am.
Tomorrow we are going to complete our syllabus. Okay, from Monday we'll discuss first question bank one by one, unit wise. Okay.